Hi everyone, welcome back. My name is Gurumurthy M, Assistant Professor, Jyoti Institute of Technology. So far, we discussed about classification of follower. Today, we'll discuss about classification of cam. According to the type of follower motion, according to the shape of cam, according to the manner of constraint of the follower, the cams are classified. And the first one is according to the type of follower motion. Here, depending upon the cam profile, follower will have motion. See, depending upon the profile of a cam, this follower will have motion. So that is why it is based on a type of follower motion. The first one is dwell, rise, dwell, return, dwell. Shortly it is called as D or D or D. So before moving on to this, many of you heard about rise and return, but the dwell is a new word. It is like a taking rest for some times. That is, there is no displacement of the follower. The displacement of the follower may be zero. It is at some resting condition. Okay, so that is called as dwell. For example, in this animation, where there is a constant radius, there you have no displacement of follower. There is no displacement of the follower will take place. So that region is called as dwell. If it is having some bulged portion, then this follower will have rise or return motion. Okay, so when it comes to this D or D or D, let me explain through this profile. This is the initial position of the follower. Here the radius is 50 mm. Here the radius is 50 mm. It is same from 0 degree to 45 degree. So that is why there is no displacement of the follower here. Okay, it is constant, that is 50 mm only. Next, after this 45 degree, it will rise up to 65 mm for the next 90 degree. That means it is rising from 50 mm to 65 mm. That is, the displacement of the follower is 15 mm. Next, again it is having constant radius, so there is no displacement at this region. So that is why this 45 degree is dwell region. Again it will return for next 90 degree, that is 65 mm to 50 mm. That is return of 65 mm to 50 mm, that is 15 mm reduction in the displacement. Next, for next 90 degree, it is dwell, means 50 mm only, constant radius. So totally you should have 360 degree for the complete rotation. Okay, this will be explained through displacement diagram. So this is called as a displacement diagram. In the y-axis it is having follower displacement, and in the x-axis it is having cam angle. This is 0 degree. So here the cam already at 50 mm position. Next, for 45 degree, from here to here, this may be 45 degree, 50 only, so there is no displacement of cam. Next, from this 45 degree to 90 degree, it is rising from 50 mm to 65, that is the displacement is 15 mm. Next, constant radius, that is dwell for next 45 degree, dwell, that is 65, constant for 45 degree. Next, return, it is returning 65 mm to 50 mm for next 90 degree, that is why it is return. Then next 90 degree is 50 mm, it is constant. Again this cycle will continuous. Okay, so this is about dwell, rise, dwell, return, dwell. And the next one is dwell, rise, dwell, fall. In case if the profile having cut like this means initially it is having dwell period, next it will rise, again it will have dwell, then it will falls. Okay, suddenly it will drop from the top, there is no return. Okay, suddenly it will falls, again it is having dwell. Correct? See, rise and drop, dwell, rise, so dwell, again drop. So this is the example how this cam will be used for the application. And the next one is dwell, rise, return, dwell, DRRD cam. See, there is no dwell period here. In the initial position it is having dwell, it will rise, there is no dwell, suddenly it will return, dwell, again rise, there is no dwell, it will return, again dwell. See, this is the best example. Dwell, rise, dwell, dwell, rise, dwell. Sorry. Dwell, rise, return, dwell, dwell, rise, return, dwell. Next, here you don't have any dwell. Rise, return, rise, rise, return, rise, return, rise, return. There is no dwell period. There is no rest for follower. Okay. Next, according to the shape of cam, it is classified as follows. The first one is wedge or flat type. The next one is radial and cylindrical, globoidal, spherical, conjugate, and spiral cam. First, wedge type. It's a very simple one, as this wedge move back and forth, this follower will reciprocate. This is of wedge shape, so that is why it's called as wedge cam, as it will operate back and forth. This will have translatory motion. Even it may have groove like this. In this groove you are having roller, as it move back and forth it is having translatory motion. Next, this is radial cam, because this cam is having radius or variable radius. So as it rotates, it will reciprocates, or it is having translatory motion through this guideways. Are you getting my point? Okay, so there is no confusion between radial cam and radial follower. In case of radial follower, the axis of the follower will pass through the center of the cam. Correct? If it is not passing through the center of the cam, then it is called as offset follower. But in this case, in this radial cam, there is no offset. Offset options means if it is having offset, then also it is called as radial cam. If it doesn't have any offset, then also it is called as radial cam. But in case of follower, if it is passing through the center, this axis passing through the center, then it is called as radial follower. If it is having offset, then it is called as offset follower. This is also one more example for radial cam, because it is having radius. This is also called as yoke cam or positive drive cam. This will be explained in the upcoming slides. Okay, as it rotates, it will have translatory motion or reciprocating motion in the guideways. And the next one is cylindrical or drum cam. On the surface of this cam, it is having groove. This is in cylindrical shapes, so that is why it is called as cylindrical or drum cam. On the outer surface, it is having groove. In this groove, this follower will have roller. So this will follow this grooved path so that it will oscillate as the cylinder rotates. globoidal cams. It is same as that of your cylindrical cam, but it will have convex shape at the outer surface or else concave shape on the outer surface. It will also oscillate as it follows the grooved path. And the next one is spherical, because this cam is having spherical shape and also it is having groove on the surface, and this is followed by this follower with roller. Fine. As it rotates, this this follower will oscillates. And the next one is conjugate cam. This conjugate cams, also called dual cams or double disc cam, and they are bolted together. They are mounted on the same shaft and also they are bolted together. Okay, because of this contact of these two rollers, they are always in contact with these two cams. Because of this contact, there is less noise of the follower, and also you can have better control at high speeds. Okay, if the machinery is operating in a high speed, or you need some less noise, in that case you can use this conjugate cams. For example, for application purpose here, if you are using pick and place robot, for example, okay, with the help of sensors and all, in that case you can use this conjugate cams. See, so that you will have better control on the speed of this machinery. Fine. And the best application is shaft motion carpet weaving machines. Next is and this is the last one, spiral cam. On the surface of the cam, it is having spiral groove. On the path of this spiral groove, this follower will have motion. So that is why it is having translatory motion, or sometimes it may have oscillatory motion. Okay, this follower will have a motion, or this follower will follow this spiral path, so that it is having translatory motion or else oscillatory motions like this. You can observe in this animation. And the next, according to the manner of constraint of the follower, it is classified three types: a preloaded spring cam and a positive drive cam, and the last one is gravity cam. Here the cam and the roller are in contact. How? Because of this compression spring. This compression spring will force this roller to make contact with this radial cam. Okay, these two are always in contact because of that compression spring force. So that is why it is called as preloaded spring cam. And this is also preloaded spring cam, but it is also based on shape. It is called as wedge cam. This is radial or disc cam. This is called positive drive cam. In this case, there is no need of external force like spring. Okay, you are not provided any spring over here, but it is completely constrained. Okay, it is completely constrained. As this cam rotates, this follower will reciprocate, and there is no need of external force to make contact between these two cams. Fine, because it is completely constrained. That is why it is called as positive drive cam. In case of positive drive cam, there is no need of external force to keep cam and follower in contact. This is also called as yoke type cam. Here gravity cam, in this case you need gravitational force to make contact between cam and the follower. Because of gravitational force, this roller is making contact with this cam. Here also, because of gravitational force, this roller is having contact with cam. So today we'll wind up this session. In the next class, we'll go through nomenclature of the cam. Thank you.